Hi, everybody. Okay, cool. So yeah, where's Ryan? Ryan's around here somewhere. But yeah, we're going to talk about TestTrack tonight. So first things first, what is TestTrack? So we built TestTrack to be a robust, performant, feature gating and split testing framework. So we designed it for Betterment's model for building software, which is a fleet of small teams that are loosely coupled, building serious business logic heavy applications. And we've been refining this tool in-house for about a year now, and we're making it available today as an open source product. Thank you. So yeah, just to get it out in the open, the project status is the core functionality is definitely production ready and battle tested, because if it weren't, then we wouldn't be getting data right now. But the provisioning and consumer documentation is very much in beta. So we are looking for as much help as we can get from you guys if you're interested in checking it out. PRs are definitely welcome. And if you haven't participated a lot in open source, documentation is a really great way to get your feet wet. So we'd really appreciate that help. Cool. So why did we build yet another split testing framework? RubyGems.org is littered with A/B testing frameworks. So what makes this so freaking special? So yeah, like Betterment has been data-driven since the beginning, and we strongly believe that to make good decisions, you have to test and measure everything that you do. And as a result, we've actually had a powerful but somewhat clunky ad hoc split testing framework for a long time now. But we needed some new things as well. So first of all, we had to not have any regressions in the functionality that we already had, but we needed fewer sharp edges because our existing tool you had to manage through SQL DML queries and stuff like that. And we just wanted better tooling across the board. We needed to level up because when we started, we were a monolithic application, and now we're this fleet of startups model. So we needed to be able to support that ecosystem. And finally, we wanted better performance and scalability because the existing thing was sort of bonking against a couple of limits here and there, and it was kind of getting expensive to just keep running. So what did we need that it already had? So we had consistent experiences across devices, which is actually like kind of a big deal. We needed the ability to override assignments and change assignment weightings on the fly from the server side without customer interaction. And we obviously needed trustworthy data to make good decisions, but one of the things that some of the larger products out there have going for them is that they've got just an insane fire hose of data. And they can basically just turn off a split, throw out the data, put it up again, and 5 hours later they've got statistical significance. That's not the kind of world that we live in. We've got a smaller product. Every impression counts, and we want to be able to actually measure small but significant changes in as little time as possible. So in addition to that, we wanted better tooling around setting up and managing splits. So we decided to actually outsource the analysis phase of this stuff rather than trying to build it ourselves. Mixpanel has great funneling stuff for basic split testing capabilities. And we also have an amazing data team here with fully staffed with PhDs to do complex analysis in R when the need arises. We wanted self-serve split reassignment for team members so that you can turn on and off features for feature toggles and see what different customer experiences will be in the various states. We want really great performance for our customers because I don't know if you've used a lot of stateful split testing frameworks before, but they often introduce like borderline untenable amounts of latency to your app in order to get back the features that you want from a split testing standpoint. And then we also wanted to use a migration-like workflow for getting these splits out through our environments. We have various different kinds of environments for testing, for user testing, for various phases of staging and stuff like that. And we wanted to be able to actually empower our PMs to make decisions about our splits without involving software engineers. Okay, so the next thing that we needed was great integration with this fleet of startups model. So right now we've already got a retail app, which is what our customers use to manage their assets. We've got Betterment for Business, our 401k product, Betterment for Advisors, which allows advisors to advise their customers on our platform. And then we're also on the other axis, multi-platform with Rails, Backbone.js, WordPress, and mobile all happening at the same time. So all of these teams need to be able to deploy tests individually without talking with each other. but occasionally they all need to collaborate with each other about these really big cross-functional split tests that might impact something all the way from first hit on the brochure site all the way through the trading internals. So it made sense to us to not make TestTrack part of any one monolithic system, but actually just make it a thing unto itself that all of the other applications coordinate with and use as they see fit. So we also wanted better performance and scale. So this would be an easy thing to overinvest in, we thought. So we actually were just like, okay, take a breath. We're not going to go after hashtag web scale here. We're just going to try to get together reasonable big O stories about how we access our data on well-indexed relational database tables, skip the N+1 queries, no full table scans, and no overwrought data modeling involved. And we actually found that that was incredibly successful for us. Right now, on relatively high traffic days for us, we're pushing somewhere around 3,000 requests per minute via TestTrack with 15 millisecond response times on all of the server high traffic endpoints. And we're doing that off of 2 C4.large instances. Royce is fact checking me over here. Excellent. So yeah, and that's using about 25% of the CPU on those boxes, so we're actually burstable up to more than that. And yeah, obviously, that's great for right now, but eventually we expect to be bigger, as I hope all of you guys do as well. So we tried to design a contract on the outside of this server that would allow us to swap in something more serious on the inside. So like fundamentally, there's nothing not inherently shardable about the data that goes into this thing. It's really about my visitor, what I'm assigned to, so there's no reason why this can't scale out on the inside as we need it to. Okay, so now we know we have all of these requirements, right? Pretty big deal. But what inspired us about other solutions that we saw out there? So for starters, Adam, who I don't know if he's here tonight, built a stateless client-side hash-based deterministic split testing system as an R&D project. So the basic idea is that the client would assign a random identifier and then basically from that determine what variant of what split you'd go into from a constant set of weightings, right? That allowed it to be incredibly fast because on first hit, you've got all the data that you need to assign yourself, you assign yourself and you go. There's no extra ping pong to find out what split you should be assigned to, you decide for yourself. But that comes with some obvious limitations, right? So there's no cross-device consistency because there's no central data store for anyone to know what your assignment as a human is. So there's no way to reconcile your mobile app with your web app. You couldn't override your assignments for individuals remotely, so I couldn't go in and say these 10,000 users with these qualities about them need to flip over to this other variant. And you couldn't change the assignment probabilities at all without randomly changing the experiences of users in the field because all of that hash bucketing would change. We really like the contract of the KISSMetrics A/B tests that are built into their JavaScript client. So KISSMetrics' backend allows client retrievable visitor properties. So you can actually push in a value and get it back out unauthenticated as a JavaScript agent, right? And with that and just a little bit of JavaScript glue code, you can totally make a split testing framework. And that it's really easy to work with, but it has another set of constraints. So it's only available in the JavaScript client for them. They had no centralized management of variant probabilities because each split would actually encode the sets of variant probabilities right in line in the code. There was no bulk overriding of assignments from the server side or anywhere else. All splits required a ping to KISSMetrics in order to determine, whether there was an existing assignment. So basically, you'd end up with this visible latency whenever you wanted to do that. So like if your home page had to decide what to display, your user would get like a painted blue Betterment screen with nothing on it. You wait half a second, then suddenly pop, your correct variant pops in, and that's not acceptable for us. And there isn't really a credible security story around KISSMetrics because anybody can modify those splits, so anybody can be in any variant at any time. So, what did we do differently? Okay, so I've probably beaten this horse to death mostly, but we decided to use a standalone server. And the reasoning behind that was just that deterministic assignment is attractive, but we need to be able to override people individually. And then the fact that we've got a bunch of different consumers in our org didn't make sense to couple it to any individual app. And then finally, we could also architect this so that if TestTrack, despite the fact that we tried to design it to be super reliable, super fast, if it went down, we wouldn't like that to bring anything else down. So it's very easy to build the contracts into those clients to accept TestTrack that doesn't work right. So the second choice that we made was we chose to use thick clients. So the key constraints on us here were you get to choose between time to glass, stateful overrides, and the ease of build of the whole framework and system, right? So we chose time to glass and stateful overrides, and then we ate the ease of build problem because those clients are not the easiest possible solution. So we actually do a hybrid stateless assignment. On first visit, we can assign with 0 network latency, and then afterwards we've done a bunch of optimizing in order to try to reduce it as much as possible. Yeah. So let's take a look at just the overall design of the system. So there are 3 major required components, 2 of which we provide. There's the server, which I was talking about. So that's a Rails app that you just download from GitHub, and you deploy it on Heroku or any other 12-factor deployment you use. And then there's this TestTrack Rails client, which is a gem which you install inside your 1 or more server-side applications. And then you hook that up to Mixpanel, Segment.io, some third-party analytics sync for your events. And then we have these other fancy things that we've bolted on for ourselves as well, which is a JS client, which allows us to use it in non-Rails environments, and a Chrome extension, which lets our developers and PMs try out different splits for themselves. So what does the server itself provide? It's an API and single source of truth for the system state. It has all the running splits and their variant names and weightings. It has the assignments of every visitor who's ever come to the site. And it has mappings between those visitor IDs and your app-specific identifiers, like your user ID, so that we can use that to merge visitors together when somebody signs in and get that consistent experience across devices. The server also provides an admin panel for PM so that they can come in and make modifications to the probabilities of different variants. They can do bulk reassignments, and they can decide splits when they're done. But the server isn't, as I said before, an event store, so we're not shipping actual analytics data to it, and we're definitely not analyzing the results of the splits using the TestTrack server. We do that on other things. The Rails client does 3 things. First, it provides a DSL to deploy split configuration to your TestTrack server. That's done via Rails migrations. You literally just commingle these with your SQL migrations, and they just work. You don't worry about the fact that they're not technically shipping SQL. They're actually just shipping HTTP requests to an idempotent API, so you can continue to run them, and they'll roll out through all of your environments nicely. It's got an automatic visitor identity management system, so that's where some of the gnarliest code in these clients lives. It figures out how to deliver the most consistent experience possible to your customer, regardless of whether they come in from one device, then another device, then switch back, then their spouse logs in again, and all of these annoying merge problems. But we solve that so you're focusing on your splits, and then it provides this high-level API to exercise the splits, which are basically glorified if statements. Cool. So let's talk a little bit about time to glass and how we optimized for that. So the first tier of this strategy is if you have no state, you have no latency. So when an uncookied visitor arrives at our app, the client generates a random visitor ID. This is very much like Francis, which I was talking about before. It calculates an appropriate variant on the client side based on the cached weighting information, also identical to Francis. And then it asynchronously writes to TestTrack after the page has already been rendered. So at this point, we've taken no performance hit, but we have stayed on the server side. So this is pretty great for things like TV ads and other new visitor spikes, full-featured split tests on your public homepage with confidence under load, which is pretty cool when you actually get down to it. Okay, so obviously that doesn't work for everybody, though. Like, you have steady state traffic, people who've been here before, you need to show them the same variants that they've seen. So there's another significant win that we can get here, particularly for the JS client. The thing that was sort of the Achilles heel performance-wise for KISSMetrics was that, let's say that customers on the other side of the country, they come to you, hit your page, and then your page says, okay, here's the content. Now the client comes back and says, okay, so what are my split variants? And you've just got 2 cross-country round trips, right? So we had the somewhat obvious insight that our LAN latency is a lot better than that. So what we actually do is when a request comes in to our Rails server in turn hits the TestTrack server over our itty bitty latency inside of our data center, gets all of the variants for that customer, and spits it back out in the HTML page to the client side. Now suddenly the JS in one request has all of the content necessary to make its split decisions. So it reduced the time penalty from 2x your internet ping to 1x plus a little bit. And that was a huge win for us, allowing us to effectively get almost no cost even for the stateful split tests. So yeah, now Ryan's going to come up and talk a little bit about TestTrack and how it's shaken out for us in practice.
Thanks, John. Hey, everybody. I'm Ryan, if you haven't gathered that by now. So let's talk a little bit about where we're at now with TestTrack, and we'll start with how we actually use it and what we use it for. We use it for A/B testing and feature flags. No crap. It's sort of important to talk about like the similarities and differences because in a lot of ways they're the same thing. They enable code paths for some users, but not others. We spin off metrics and collect those to see which users hit which code path. We figure out which code path we like best, and then we throw the rest away. They're also a little bit different. A/B testing is generally used to show users experiences across one or more variations, so you could have like 3 or 4 or a million. Probably that's a bad idea. The experiences that tend to be visual, so these are going to be things like copy changes or image placement, calls to action. You see sign up now versus join today. Like it seems like it'd be the same, but you know people respond differently to those mentally, and you don't know until you test it. And they're usually intended to drive a very specific user action, like sign up for our service, give us money, etc. Feature flagging is a little bit different in that you usually deploy with everything turned to 0, and then you have the option to slowly ramp up access to a new feature or like a new endpoint or something. This is super important because it decouples your feature introduction from your deployments. In a previous life, I worked on like a monitoring and alerting team, and we did some research, and we found that over half of our incidents, like company-wide, were introduced at deploy time because code with bugs were introduced. If that code is behind a feature flag, you can A, only show it to a certain amount of users, so you find out it's a bug and only a few people saw it, but B, you also get really granular rollbacks. All you have to do is turn it off. Some quick numbers. We've been in production for a little under a year. We've got somewhere around 1,500 GitHub commits, 20 different contributors. We've run about 90 splits, which seems like a kind of low number, and it is. About half of that has been in the last 3 months as we migrate off of the legacy system that John was talking about. So we're leaning against this harder and harder and harder, and the more we do, the more we like it. So how to use it. First thing we got to do is actually add a split. So TestTrack provides this nice update config helper, and the split function there is actually how you both create and update a split. So if you wanted to change your weightings at deploy time, you could do it via a new migration that looks exactly like this, just with the weightings that you want. Similarly, a drop split does exactly what you think it does whenever you're done. So, quick client overview. Most of us use it in controllers. There's some ways to use it outside of controllers. We found that like most of what we need it for is in controllers. So there's this nice little mix-in TestTrack controller, and it gives you access to this TestTrack visitor attribute, off of which hangs the functions you need to access to see what split the given user is in. And that looks a bit like this. You see one up here is a simple A/B test for an action button, sign up now versus join Betterment. And the one below is the A/B is the same function name we use for feature toggles. This one is showing a menu item for our cool new beta product for some percentage of users. There's also the vary function for n-way splits. So if you have 3 in this case, or 4 or 5 different variants, then you would use this one. And that's pretty much it. So, admin panel on the TestTrack server gets you pretty much exactly what you would think. You get a list of all your active splits, their current weightings, and the app that they're running in. You can drill down in from there. From here, you can do bulk uploads or bulk assignments if you have like a list of user IDs that you want to be in a very specific variant. You can do that from here. You can decide the split, which basically just puts everybody in whichever variant you want and then turns the rest to 0. Oops. And you can also change the weights from here. So this is where you can do those feature rollouts totally decoupled from deploys and live in real time. So evaluating results, like John mentioned, we use Mixpanel. You're not tied to Mixpanel in any way, but since we do, that's what we're going to see here. So in this case, we have a new sign-up question test. I'm not sure what that does, but we look in our funnel for step 1. A user was assigned to that test, and then the metric we wanted to move in this case was deposit completed. These are just kind of made up for the record. And so we let it run for a few days. We had about 50,000 people get assigned to one of these splits. Looks like about 20% got the new design and about 80% got the original. In this case, you can see that the new design actually underperformed the original by a significant amount, like over 10%. So in this case, that new design was rolled back, and we stuck with the original one and kind of went back to the drawing board. We don't view these as like failures or like a hypothesis failed or anything, but more so we just now know what our users don't want to see. So we learned something from it. In fact, what we've learned. Don't overload your splits. There's some situations that people get into where you think it makes sense to have a feature flag and an A/B test in one split name, and it's a bad idea. From an analytics perspective, you want your A/B tests to run with the same weightings for as long as possible, or else all your math gets messed up. And with your feature flags, you want the ability to turn it up and down sort of willy-nilly, however you need to do it. So in this case, what you do is you make a specific feature test or feature split, and then within that, you do your A/B split. Start with a measurable hypothesis. Don't just go start writing code and then wrap it in splits and then like go find metrics later and see what happens. You want to have sort of like small, controllable, and really highly measurable experiments. Something I think a copy change to XYZ will lead to more AUM for Betterment, and then your measurable piece of that would be obviously total deposits. Also test for regressions. This isn't like regressions in code. This is regressions in metrics. It's not good enough that your experiment positively affected whatever metric you wanted it to. If it negatively affected 3 other important metrics, that's something you really need to consider when deciding whether or not you want to move forward. The data does not lie. So you just worked for 3-6 months on your new feature, you roll it out, and the adoption is really poor. The users don't like it. It's turning people away. It can be really easy to start sort of like grasping at straws in the data, looking for any reason to keep it out there. Just don't do that. Easier said than done. So maybe what we like to do is have a separate analytics team actually evaluate this data for us, and they're really objective. They're not tied to the feature emotionally like you would be. And get statistically significant results. If you don't do this, you're just guessing. That's really all there is to it. There's tons of calculators out there. Just use one. And manage splits in your issue tracker. This one is one that we kind of like doing a lot. If anyone has ever used a sort of split testing library like this before, you know that after like a month or 2 months, you've got all these splits out in the code and in the database, and no one knows what they do or how long they've been out there or if they're safe to turn off. So by managing the life cycle of your splits in an issue tracker, we sort of like defeat that problem in a sort of like unscalable manual way without doing a bunch of crazy technical solutions for it that generally don't work anyways. And it's also a nice place to keep like screenshots and description of what the test is doing and maybe even results. Okay, open source TestTrack. So we originally built TestTrack with open source in mind, but no target release date. So what that sort of ended up in was this roadmap of where a lot of it was like really tight open source code, but then some of it wasn't. Just add that feature real quick and we'll fix it when we go to open source it. And you do that over time, and then all of a sudden it's too much. So we were sort of getting like some of the drawbacks to open source, but none of the benefits of actually having a community around this. So we sort of decided like, let's actually do this. So just a few months ago, we like started to push internally and got this project on the roadmap for Q4. And special thanks to John Mileham over the last 2 weeks, but also all of our contributors. We are now open source less than a month into the quarter. Yeah. So this is where you all come in. Future work. We don't have any mobile clients right now. We have some of that work slated to begin also in this quarter. So that's probably going to start in-house, so maybe don't start there. But other languages, this is a Rails meetup, so this is kind of like a plea. But if you're out there like learning a new language for fun or something, and you're looking for that project that is like substantial but not overly huge for you to learn this language in, this could be a good opportunity. And some of the things that we could either improve upon in the existing code is, so we have analytics and authentication solutions. Those contracts will likely evolve. They were put together somewhat quickly, and there's probably a more better way to do it. And also our logging situation, it's not pluggable at all. And in general, this is our first substantial open source project here at Betterment, and it's by far and away not our last. Our open source culture here is just in its baby phases. We've got a bunch of other internal projects already targeted for potential open sourcing, some data pipelining stuff, some HTTP testing utilities, front-end styling frameworks, and a whole bunch more, and who knows what more. So as always, we're hiring. Come work with us. And special thanks to all the contributors on this project. I will give you a moment to read all these nonsense names. And that's all. Okay. Any questions? John, you want to join me? Since you have all the historical context? Good. Yeah.
Can you talk a little bit about the visitor reconciliation and merging process?
Yeah, the question is, can we talk a little about the visitor and merging reconciliation process? I'll give us a go, and we'll see if John has anything more to add. But effectively, every client that hits you via a browser gets a cookie assigned to them, and that cookie is their like sort of canonical visitor ID that is their sort of primary key in TestTrack. But then also it's nice to know that like that primary key is also this user ID, like in your actual app. And so that merging process is just the process of associating multiple identities as one like super identity. Is that a good enough job? You want to add to that?
Sure. I mean, I could go deeper. Do you want to go deeper, or are you satisfied with that? You want to go deep? Okay. Let's do this. No. So yeah, the way it works is right. You get a visitor ID. It's stamped by the client. Whenever you sign in or log in, you sign up or log in, we're going to send that event off to TestTrack that pairs your visitor ID with that user ID. There's only allowed to ever be one visitor ID associated with any given application identifier, like a user ID. So you basically claim that user ID for your visitor ID. Next time someone comes in and they're not your visitor ID when they go to sign in, what's going to happen is it's actually going to say, oh, that's not going to happen. I'm not going to be able to assign this. So what it does is it overlays all of the things that you as the new visitor have experienced that the canonical visitor for that user has not experienced yet, and merges them together into the assignment bag of the canonical user, and kicks back the visitor ID of the canonical visitor. So you become the visitor that you were before, and we basically retire that ephemeral visitor that you had. So basically, you're going to have potentially some inconsistent experiences before login because we just didn't know who you are. Sorry, but as soon as we know what that is, we will slap over whatever you experienced brand new in the new visitor over anything that we'd already baked for you in your previous experience, trying to give you the most consistent experience throughout.
So will you actually rewrite all the events? I guess like the identifiers that they had for the previous experiences, like all the events that were tied to that. Will you rewrite what canonical ID they had? Will you update those events? Or
so it's actually the canonical identity that wins. The canonical identity never changes assignments. What happens is if we find any empty spots in the canonical identity, we'll slap in the new assignments that happened from the ephemeral visitor onto that. Cool? Awesome.
I feel like a very common issue with a lot of different split libraries is when you sort of have this like Venn diagram effect where when you use like the Mixpanel example, you're running a funnel where you're like, I was bucketed into this experiment and I know this thing succeeded, but that user could have theoretically been bucketed in 7 other experiments, so it's kind of hard to potentially see where, unless there's a limitation where you can only be in one bucket at once. Did you guys run into that issue?
So you're talking about when you have too many tests going on at once and they're conflating their results? So one of the things, our fleet of startups model is supposed to actually fix that on a cultural level a little bit by having, teams actually own a whole subdomain. So by and large, they will limit the number of tests in flight in a given domain. So like the retail team is broadly aware of all the splits that are being run on our retail users at a time, and they're thinking hard about how many things we want to vary in proximity to one another on the site. So by keeping that ownership localized inside of a team and people being proud of the output of their specific product, we mitigate that. But that's definitely an issue, and it's just something that humans have to do right, kind of. Yeah. So we'll start from the left. How's that?
I just have a question about, have you guys thought about segmenting feature flags or A/B tests? Like, for example, let's say you have Eastern and Seaboard people or East Coast people, just having something that would be just available to them. Have you thought about that?
Like geo-targeting availability of
For
splits?
Maybe like the first time user would be like an East Coast user could do by like state, country, city, etc.
Yeah, that's really interesting. We haven't had to get into that very much. So that's one case where like the feature gating side is all about that. The split testing side, that would probably be a disaster from an analysis standpoint. But yeah, that's actually a really really good thought. We haven't begun to think about that. But like it makes a lot of sense that you would be able to choose who gets what based on where they're at.
Do you guys use this on your public-facing website? Like if someone goes to Betterment.com, and if so, do you guys do edge caching, like where you cache the HTML and everyone maybe gets the same page?
Yep.
And so how does the library work with that?
Yeah, so that's where the question was, do we do edge caching? And how does that impact the feasibility of using this tool? And we totally do on our brochure site, which is a WordPress site. So that HTML is burned at deploy time, and actually what happens in that situation is we burn in the set of split variants and their weightings, but we're not able to leverage that super fancy channeling the visitor assignments through because did we put that in PHP? We might have. I don't remember, but it would be possible to plumb it through the PHP so that worked for that. But we still do get the benefit of first hit, and on the brochure site, all of our interesting spikes are always going to be those unwashed, never seen before visitors. So it's actually pretty good for the tier 1 strategy. But the tier 2, we either have, and I don't remember if we have, or we could plumb through those visitor assignments by building a more fully featured PHP client. But yeah.
So you mentioned that there was a Rails client that was required. I understand there's a Rails server, like experiments. Rails client that's required. JavaScript required. So say I have a single page app that doesn't have its own app. Is that a feasible? Is that something they use this without having a Rails client?
Yes. So the question is, can you use it without the Rails client? We said the Rails client was required. Why is it required? So the Rails client is required only because that's the only tool that's capable of running these migrations. We found that the migration aspect is really, really key. So what we did in our case for our brochure site is we embedded a Rails app into our brochure WordPress repo that only serves to run migrations. So yeah, you just need something that's capable of authenticating against the server to change these split weightings and stuff like that. So if it just means shipping an extra artifact alongside your single page app, then that's totally feasible. Yeah.
You have when the request comes up, you make another request to your TestTrack server to get the splits right. So where do you actually plug that in on the Rails framework?
Yeah, so getting the splits and their weightings, the sort of like truthful value for everybody, that's obviously low rate of change. We actually cache that in memory in the Rails server process for about a minute a pop. So those things get injected into the Rails client's runtime out of that cache. They also get burned into the page for the JS client if it's listening. So we get really, really low traffic on our TestTrack head end for those kinds of requests. The significant traffic is coming for those visitor-specific assignment bags that we hand out. So we just needed to make that fast and low cost, and it's been very successful at that. All right. Well, thanks, guys.